Hello. In these episodes, we're going to talk about the Formula One power unit and give you some insight into each of the elements within it. In this first episode, we're going to talk about the internal combustion engine, the ICE. The ICE is very much the heart of the power unit, creating most of the performance and power. It interacts with all the other elements on here through the compressor and turbine wheel, MGUK, through the link with the crankshaft, and it links with the power electronics through all the controls of all the systems. So it's the part that takes the fuel and converts that into the motion of the crankshaft that drives the wheels. But very much it's the beating heart, the internal combustion engine. The drivers have 3 internal combustion engines to last them the season. The internal combustion engine is the component of our PU that is most similar to what you have in your car. The elements of the combustion engine, the crankcase, the cylinder heads, the crankshaft, the pistons, the conrods, the way that it operates using the 4-stroke cycle and increasing the thermal efficiency from what you might see in your road car of about 30% to the F1 power unit of over 50%. And you probably recognise terms like inline or V. This is a V engine, a V6, 1.6 litres. So all things you might recognise from your road car. Where it's very different is some of the details, and it's really in that detail that it is different. So we have an engine that's rotating at 15,000 revs per minute, significantly quicker than you would on your road car. That means that the combustion's happening ever so much more quickly. So within the blink of an eye, we have 200 combustion events. And that is so much quicker, and the detail that has to go in to make that work and to make that produce the power that we need to power our Formula One car, that's where the differences really lie. You might ask if the real differences in this engine to road cars are in the details. Does anything that we do in Formula One trickle down to a road car? And I think it does. On the one aspect, there's the way that we develop the engine, the techniques that we use, the computational fluid dynamics. And really, when we speak to our colleagues in Stuttgart, they're very interested in how we do that and the details of how that's done and if they can use some of those techniques too. But also in the very, very heart of the combustion chamber, in the way that we make the explosion happen in a controlled manner, there's some real detail in there that is trickling down to the road car. In terms of statistics on the combustion engine, it's a little bit difficult to split them out from the power unit. So if I give you some numbers around the whole power unit, this power unit, when it's flat out, is producing in excess of 1,000 horsepower, powering that car down the straights. Some of the aspects of what's happening inside the combustion engine are quite breathtaking though. If you consider when we have the combustion event happen in each cylinder, the temperatures are in excess of 2,500 degrees centigrade. And also at that point, the load that's on the top of the piston is in excess of the weight of 4 elephants. To be able to harness all that energy and all that power and convert it into crank power, that's what the internal combustion engine does. The challenge we at HPP have every year is to develop the engine further, to make it more thermally efficient, to make the performance that comes out of the back of the crank even higher. And to do that while still only being able to have 3 per season and therefore be able to keep the engine reliable in order to develop that power, hold it all together and deliver it at the right time at the circuit. That's our big challenge. The PETRONAS fuel and oil are completely integral to everything that happens within the internal combustion engine. So that's where the design of the combustion chamber and the fuel are done together to make sure that we can convert that fuel into the largest amount of energy that then can be turned into the power at the back of the crankshaft. The oil, PETRONAS Syntium, is integral with every moving part in this engine. So if you consider those forces we talked about earlier on the top of the piston being transferred all the way through the crankshaft, then the oil that makes all those joints work is absolutely key to keeping the performance of this engine and the reliability of this engine. Hopefully you can see that the relationship between Mercedes and PETRONAS has to be incredibly close so that we design the lubricants, the fuels, together with the engine to make sure that what we deliver to the track is the best that we can. So that's some detail for you on the internal combustion engine. For the next episode, we'll be talking about the turbocharger.